Do you ever stop and think about how a huge place, like a university campus, even begins to track its electricity bill? Well, today we're diving into a really cool student project that literally sheds some light on that exact problem.
I mean, just think about that for a second. How would you ever try to save water with so little information? You'd have no clue if it was a leaky faucet, maybe someone taking super long showers. You'd just be guessing in the dark until the bill arrived a month later. Kind of crazy, right?
Well, believe it or not, that's pretty much the reality for a lot of large campus buildings. They get one single massive electricity bill at the end of the month, and they have almost zero insight into what was happening day to day, let alone minute to minute.
And the difference is just night and day. On the one hand, you're basically flying blind with a bill that's a month old. Maybe a faulty air conditioner ran all weekend, or a whole lab floor was left on by mistake. You'd never know. But with the better way, you've got a live feed. You can spot those problems the second they happen. It is a total game changer.
So, you're probably asking, why isn't every building doing this already? Well, the short answer is, it costs a ton of money. Commercial systems, the professional-grade stuff, can easily run you over R500,000. And that's a price tag that's just way too steep for most schools or small businesses.
And this right here is where our story gets really interesting. A student at the Cape Peninsula University of Technology decided to take on this massive challenge for their final year project.
So, the official goal was pretty ambitious. This wasn't just about counting watts. The aim was to build a low-cost system from the ground up that could monitor a three-phase power supply, and that's the heavy-duty electricity that powers entire buildings and big machinery, not just your desk lamp. And the best part? Make all that data available to anyone, anywhere, in real time.
And what's amazing is that the core hardware is incredibly simple and affordable. On the left, you've got the ESP32. Think of it as the system's cheap, Wi-Fi-enabled brain. And on the right, you have the PZM004T sensor. That's the meter, the thing that does all the heavy lifting, measuring the building's electrical vital signs.
Okay, so how do these simple little components come together to create such a powerful system? Let's follow the data on its journey from the physical wire all the way to the web.
This chart just breaks it all down perfectly. You've got the PZM meters, which actually measure the power. Then the ESP32, the brain, reads that data and shoots it out over Wi-Fi. ThingSpeak acts like a cloud database, catching and storing those readings every 15 seconds. And then finally, platforms like Grafana and Netlify turn all that raw data into the beautiful, easy-to-read dashboards we're about to see.
So here's the flow in 4 simple steps. First, the sensors clamp right around the main wires. Second, the ESP32 brain processes all the readings. Third, it transmits that data to the cloud. And fourth, you see it all on your screen. It's simple, it's elegant, and it's incredibly effective.
And this diagram just illustrates the whole setup beautifully. You can see the power coming in from the left. It gets measured by the sensors, processed by our little ESP32 brain right in the middle, and then it gets beamed out via Wi-Fi to a whole bunch of cloud platforms on the right. It's a complete end-to-end data pipeline.
Okay, so the design is clever. The whole architecture makes a ton of sense. But you know what the real question is, right?
After all that time designing and building, did this student project actually pull it off and meet its ambitious goals? Let's find out.
So let's run through that checklist of the main project goals. Could it actually build a working hardware node for a 3-phase system? Could it really send data to the cloud every 15 seconds? Could it create useful dashboards? And, critically, could it collect enough data for some real analysis?
All right, let's start with Objective 1. And here it is, the assembled prototype, live and in action. A functional 3-phase monitoring node built and working exactly as it was designed. That's a huge checkmark. Objective achieved.
Next up, Objective 2, communicating with the cloud. Not only did the system work, it successfully sent a full set of readings to not 1 but 3 different cloud services. And it did it like clockwork, every 15 seconds. That's another big pass.
And what about those dashboards? Well, here's the public-facing one, built on Netlify. It makes all that complex data super easy for anyone to understand. This, along with the more technical dashboards, was a massive success. So Objective 3, absolutely achieved. And of course, the system ran for weeks on end, collecting a treasure trove of valuable data that showed everything from daily startup spikes to inefficient power use over the weekends. So yeah, we have a very successful student project. But the story doesn't stop there. The real impact, the real story, is when you look at the bigger picture. Take a look at this number. Over 95%.
That is the estimated cost reduction this system offers when you compare it to the commercial alternatives. It's just a staggering figure.
And here's the breakdown. A commercial system starts at R500,000. This student project? It came in at under 3,000 Rand. This just completely blows the doors open, making this kind of technology accessible to a whole new world of users.
So you see, this is way more than just a project. It's a blueprint. It's a roadmap for affordable, smart energy management that can be used in schools, clinics, small factories, pretty much anywhere. And because it's all open source, it's an amazing learning tool for the next generation of engineers.
Which really just leaves us with one final thought. This project proves that with a bit of clever design and some really affordable technology, we can solve huge, expensive problems. It shows that making our buildings and our communities smarter isn't really a question of if it's possible anymore, it's a question of priority.